Hello guys, this is FK, and after developing softwares for over a decade, I can tell you for free that software development is hard. Yes, softwares are difficult pieces of artifacts to manage, and the bigger your software gets, the more complex it's going to be for you to manage. The more users you get, the more you would have to add a whole lot of things that you never expected that the software solution is going to have to that solution, to make sure it doesn't crash, to make sure that it remains performant, to make sure that it scales adequately. And one funny thing is that a lot of times when a lot of fixes are being made along the life cycle or lifetime of the application to make it more scalable, to make it more performance rather, you'll notice that a lot of decisions could have been made at the beginning. That's when the software was being planned. A lot of decisions could have been made at the beginning that would have helped the process, that would have helped the software to be in a better state than its current state. So in this video, I'm going to be talking to you about 5 things you need to do before you start any software project. 5 important things, core things you need to do before you write a single line of code. That's what we're going to be learning in this video. And I hope that at the end of this video, you will craft, plan, and structure better softwares that will make sure that they are maintainable, they are scalable, and performant no matter the amount of scale they grow to be. So let's talk about 5 things to do before starting a software project. So let's start with the first thing you need to do before you start any software project. And I'm going to be breaking these 5 items into why you need to do it. That's the purpose, what to do, and what should be the expected outcome of each step. So we're going to look at the purpose, what to do, and also what is going to be the output of each step. And I've tried to order the steps sequentially, like based on the order that you're supposed to perform them. But some of them can happen simultaneously, some of them have the ability to be done in parallel. So let's start with the first step, and that is that you first need to define your objectives clearly. You first need to define your objective clearly. You need to understand what the vision of the application is, what the vision of the stakeholders are, rather, for the application, what the stakeholders want the application to solve, or what kind of problems is the application going to be solving for users. This step should be done before writing a single line of code. And the purpose is to make sure that you understand what the project is trying to achieve. What are you trying to achieve with this piece of software? What is its expected impact? What are you trying to solve? What problems are you trying to solve with this solution? And you ask yourself questions like I said, what problems are you trying to solve? For whom? Who are you trying to solve this problem for? To what end? And how much of the problem are you trying to solve? You also need to define how much of the problem you are trying to solve. What are the boundaries of the scope of the solution that you are providing? Because you can't solve everything. You can't solve every type of problem in any space that you pick. So you have to know that, okay, in as much as we're solving this particular problem, we're not solving it beyond this point. We're not expected to do this. We're not expected to do that. It will better help you understand what should be contained in your application and what should not be contained. So what do you do in this step? First, you do a thorough round of requirements gathering. You need to sit down with stakeholders to understand their vision for the project. I've said that before. You need to sit down with the stakeholders to understand their vision for the project. You need to sit down with potential users to understand what are their main pain points in the problem you're trying to solve. For example, if you're trying to solve a problem in the banking industry with an app, you want to give the users of a bank an app. What problems are you trying to solve? Is it the portability of banking? Is it to make sure that they get their credit alerts in time? Is it to make sure that they can make transfers when it's not bank hours? You need to understand what their major pain points is. What problems are they solving? What is making their work difficult? You need to understand that, so that you're not just solving something that you feel is cool, something that you feel is good. You are solving something that the users actually have a problem with, so that when your application goes out, they actually use it. Because if you're not addressing their pain points, when you release your glossy application, they won't use it because they don't need it. You're not solving the thing that hurts them the most. So you have to sit down with the potential users to understand what are their major pain points. Also, you need to sit down with the team members. That's the people that are going to develop the application, make the application happen. You need to sit down with team members. That's your developers, your solution architects, especially the technical people. You need to sit down with them to understand what technologies are available to solve this problem. What technologies do you have to solve this problem? You might want flying cars, but yeah, the technology is not available. Technology is not available. Oh, I want to solve the traffic problem. Wow, flying cars would be a good idea. Yeah, thank you very much. Wonderful idea, but we don't have the technology. So you have to sit down with your developers. You have to sit down with your engineering managers to understand what technology do we have. What technologies do we have? So knowing the technologies you have, you know how much capacity you have to be able to solve that problem. So those are the things you do at this stage. And what is the output? What is expected to come out of this process? You need to draw out something called a project requirements document. Yeah, a project requirement document, a PRD, should be drawn out of this. This document is a standard document. It's a standard. I write it a lot of times. Sometimes I've written it for companies I've worked in, and I also write it when I'm doing consultancy work. So this document should contain important details like the statement of the purpose, what it states the purpose of the project, what are the goals and objectives. It defines the project scope, and also lists all the stakeholders, so that in case anyone needs to know who to contact or where to get a particular piece of important information, they know who are the stakeholders on the project. So it has to state all that. It has to define the functional requirements. What are the functional requirements of the project? These are the core features and functionalities that should be in the application. Yeah, the tools in the applications that the users will be able to use to solve their problem. This is where it's going to be defined, the functional requirements. It should also contain non-functional requirements, because some requirements don't really they are not directly related to the activities that users are going to be performing on the app. They just increase the quality of service of the application. And what are these type of requirements? Security, yeah, how secure is the app going to be? Scalability, how well will it scale? Usability and maintainability. Yeah, those are things that are to be defined in that document. The requirements that would support all these talking points, all these the usability of the application, how easy the user would be able to use the application, how well the application can be maintained, how secure the application is. Those are things that you need to specify. Also, technical requirements. This document is like the holy grail, the blueprint of the application. So you have to specify technical requirements also. And these are the technology stack. Are we going to be using PHP, LAMP stack, Linux, Apache, MySQL, PHP? Are we going to be using Node.js? Are we going to be using HTMX or any technology? You specify those technologies there. You also talk about databases. Which database are we going to use? Which frameworks are we going to use? Are we going to be having third-party integrations? Which API are we going to be integrating with? Which deployment strategies are we going to be deployment technologies are we going to be making use of? Yeah, those are things that you need to specify. Technical requirements. Also, you need to define what the acceptance criteria is. What should be what amount of work should be done in the application for it to be accepted as done? And this can even be based on each feature. What amount of work has to be done on this feature for it to be accepted as complete? What amount of work has to be done in this other feature for it to be accepted as complete? It needs to be properly defined so that the scope of work can be well defined. And other pieces of information like project dependencies, UI mockups, process flow definitions, workflows of each of the activities that the user will be performing the application. For example, let's say sending, for you to send money from one account to another, the user has to log in, then the user clicks the transfer button, then the user types in the bank account, select a bank. All those process flows have to also be defined. What are the assumptions? What are the assumptions that you are making on the project? Probably you are assuming you are making some decisions based on a particular banking policy or the currency exchange rate. So many other stuff like that. You need to state all those things there. Decisions you've made and why you made them. Also, what are risks? What are the risks that you face, and what are the proposed mitigations? Those are all the type of information that's going to be in this document. This is a very powerful document, and it guides the development of the application. So that is the first thing you need to do when developing a new app. You have to make sure that you define the objectives clearly and you determine the core requirements, and out of that, make sure you generate a project requirements document as a PRD for the project. So the next thing you need to do before starting a software project is to initiate project management ASAP. initiate project management and define your communication pipelines. Software projects have to be well managed. They have to be properly managed. As someone that started business building software on my own, I was the CEO, the CTO, the CFO, the developer, and everything of my of my service rendering software development service rendering companies. I know how difficult it is to manage a contract, and the bigger it is, the more complex it is, the more problems you face managing all the moving parts of a particular software project. So the first thing you want to do, you want to make sure you initiate project management. And what's the purpose of this? Like I said, we're going to be breaking down into purpose, what to do, and output. So what's the purpose of project management, or initiating project management and defining your communication pipelines? It helps you create a work breakdown structure. You define a work breakdown structure, because this is how you are going to assign tasks to your team members. Yeah, this is how you're going to communicate the work to the team, and also attach time frames to it. Yeah, project management, the core purpose of project management is to make sure that resources, time, and money is well managed. Yeah, that's the main purpose of project management. Resources, that's human resources, any any service you're going to be purchasing, any stuff you're going to be using. Time and money that is going to be spent is well managed. That's the main purpose of project management. So you set up project management, and without it, you won't know how to delegate. You won't know how to say, okay, this is your responsibility. You are going to develop the application. You are going to monitor the development. You are going to approve certain work. You are going to go and present to the client. You need to initiate project management. What do you do in this stage? What do? You set up a project management tool. It's advisable you use a project management tool. You use something like Jira, Asana, Trello, or a mix of all of them. I used all these tools. I think the one I have probably the least experience with is Jira. That's from a setup perspective. I've consumed a lot of tasks from Jira a lot. So I've been in Jira a lot, but setting up Jira and stuff, now I mostly prefer using Asana or Trello. So you use one of these tools or a mix of them to make sure that you define all your tasks, you assign them, and you also set delivery dates, due dates. Also, set up communication channels. Yeah, you set up communication channels on tools like Slack or Discord. These tools come with channels, and you can create channels for each section of the work, each team that has to be in close communication. You create different channels for them. It helps you translate the project requirements to tasks. Yeah, all those requirements that you've defined in the PRD, they have to be broken down into tasks, because you can't just tell a team develop a social media app or develop the chat feature. You can't just say develop the chat feature and tell a bunch of 5 developers develop chat feature. You have to say you are going to do the UI, you are going to write the front end, you are going to write the back end, you are going to test it. You have to assign jobs to each person, and you have to attach due dates. So you break down the project requirement into tasks in those tools, and you add timing information, that's your due dates, and also you set up dependencies. What tasks depend on other tasks before it can proceed? This will help you identify blockers. So if someone is not doing their job, it might be because someone else has not finished doing theirs. So these tools, they are fully featured to help you do all this, to help you organize your project and organize your tasks, and add users, add everybody in your team, assign to them, use the calendar to add due dates and stuff like that. So even for third-party contractors, you can use it to also assign tasks to third-party contractors. You also have a way to define how you monitor the progress. A lot of times you go into Jira boards, it will tell you this is 55% complete, this is 60% complete, because a lot of times a big task can be broken down into subtasks. So as you check the subtasks, it automatically calculates the progress of the work, so you can track the progress of the workflow, of the work itself rather. And also approval, who is to approve what. You also define who is to approve what. So if someone says I'm done with this, you can set someone else and say this person is going to approve the work that this other person said they finished. That is the importance of this kind of tools. You see why project management is heavily important. I've had to manage teams with my mouth, and I know how difficult that was. So and make sure that this planning is done together with the team. Yeah, don't just close yourself in one office and just design this beautiful thing that you feel that is very perfect, and you don't even consult the people that are going to do the job. You have to sit down with people that are going to do the job, so that they can tell you the amount of workload, what their mileage is, what they can handle in a week, what they can handle in a month, what they can handle in a period of, in a quarter, in a period of 6 months. They have to tell you all these things so that you factor them into how you design these tasks on the project management tool. This is something that a project manager will definitely handle. So, but it's still one of the main tasks that you have to do before starting a software project. You define project stand-ups. You even set up meetings. How you monitor the project and how you produce feedback. Yeah, these tools, if they are well developed, they will even provide the feedback by themselves. Anybody can just go into the dashboard and see the progress. And you can share that with your stakeholders, and even it will not make you have to talk too much when you have to give status update on what is going on the project. So those are the things you have to do. What is the output? Definitely a clearly defined work assignment, well automated, where you can easily track projects, you can get reports, and also deal with blockers. Also, clear communication pipelines. You've already set up the communication pipelines. You make sure that who needs to be in a particular channel is in that channel, so that they can attend to whoever is having an issue. Team members can talk freely. They can have meetings where they can talk in person, and the collaboration is just going to be seamless. So yeah, that's the output of this stage. And that's the second stage, which is initiate project management and make sure that you define your communication pipelines. So the top thing you have to do before you start your software project, that's before you write any line of code, is to make sure you plan the architecture and design. Please plan the architecture and design. Don't do a vibes driven development. Plan the architecture and design. And this one is for the technical team. Plan the architecture and design. You can't build an application you hope to maintain without getting everyone on the same page. And the way to get all the technical people on the same page is to make sure that you pick an architecture. There's so many architectures out there that you can pick for your application. We're going to be talking about some of them here that you can pick based on the type of application you are building. So what is your architecture? Your architecture is a high-level structuring of the software system into components, their relationships, and ensuring that it meets the current requirements and is scalable for future needs. Yeah, I wrote down this definition because I just want to make sure everything is covered. But your architecture defines the structure of your application. It arranges all the components of your architecture, making sure that they communicate seamlessly and making sure that your application is easy to maintain and also easy to scale. So what's your architecture? You need to design the architecture of your application. So what do you do? What do you do in this stage? You pick an architecture. There are standard architectures you use. And sometimes people use an hybrid of these architectures. But there are standard architectures to use based on the type of app type of project that you're handling. For example, if you're building an enterprise app, you'll probably be good with a n-tier monolith. Yeah, a layered architecture. An n-tier monolith, enterprise apps don't require frequent updates. So, and layered architecture is perfect for that. In a layered architecture, you don't, because changes in the layered architecture often affect a lot of parts of the layer. Sometimes, in fact, sometimes a change in the UI can affect the database design. So, layered architectures is better for apps where you know that you're not going to be making frequent updates, and that is mostly used in enterprise applications. Because, for example, like a bank app, we're using bank apps as examples a lot. In a bank apps don't change. They don't change a lot. Rather, they change, but they don't change a lot. You can't just be changing a bank app like every single week or every single month. That's why I had a problem with Payday when they send updates every month. Like, who changes a fintech app every week? Who sends updates for a fintech app every week? So, especially updates that the users have to be aware of and implement. So, in enterprise apps, an n-tier monolith layered architecture, fantastic. If you're building a startups run fast. Startups change fast. They test things, they break, they make, and stuff like that. They change a lot, especially at the beginning stage. And they often have complex architectures. The domain is often complex, and because of a lot of moving parts. And these apps often have a lot of third-party integrations. They integrate a lot of SaaS applications, payment gateways, and stuff like that. So for this, you might want to go the route of microservices. And I said might because this is conditional. You might want to use a microservice architecture. This allows, one of the benefits of an microservice architecture is that it allows different teams to work on different features. So one team can be responsible for authentication. Another team, let's say an e-commerce site. One team is responsible for authentication, another team is responsible for the shopping experience, another team is responsible for the shipping APIs, that's the inventory and shipping APIs. Another team is responsible for application monitoring. You just have all these microservices that the API gateway routes requests to based on what the user wants to do. And when one goes down, it doesn't affect another one. That's one of the benefits of a microservice architecture, unlike a layered architecture where when one layer has problem, it affects the entire application. So if you have a complex domain, you want to pick a microservice architecture. But the problem is that you need to have a team that can handle that. Your team has to be a bit big for you to handle a microservice architecture, because like I said, different teams working on different stuff. Even if you have a team and one person is working on one service each, at the end of the day you might still end up with like 7 people, because you have 7 services that you are maintaining, and one person is maintaining each one of them. So sometimes you might not have the capacity to run a microservice architecture, and with that you can just have like a web queue worker architecture and just have different layers of the application with a message bus. Implement a message bus that makes them communicate effectively with every type of service that you need to communicate with. So you might want to look into a web queue worker architecture for a growing startup, and because it helps you to also scale, similar to how a microservice can help you scale, because you can have all these services that you can just direct messages to. They can subscribe to messages, and when events happen, you can just trigger actions to happen. But when your team grows, it's better you move to a microservice architecture. Microservice architecture also makes use of an event bus, makes use of message queues a lot. So yeah, so when your team is more elaborate, you can take your monolith. If you start with a monolith, when your team is more elaborate, you can take a monolith and break it down into a microservice. Yeah, you can do functional decomposition and break it down into a microservice, where you basically just look at the modules in your monolith application and break them into remote services, and convert it to a microservice architecture. So yeah, if you are going to be consuming a lot of data, you want to be doing real-time analytics, you want to be doing data mining with big data, you want to go with big data architectures. You want to go with big data architectures where you just have this data lake that you dump data into and mine you mine information from analytics for business intelligence and stuff like that. So yeah, also if you also need to design your patterns. You also need to implement design patterns for scalability and fault tolerance, because your architecture is how you structure your entire application. But there are design patterns that you can implement around your architecture to make sure that your application can be maintainable, can be scalable, and can stand the test of time. Because you see, faults are going to happen. There's going to be failures. One component is going to break down. One thing is going to get loose there and stuff like that. So you can use design patterns like things like Ambassador, things like Circuit Breaker. You can put load balancers to horizontally scale different components that are receiving a lot of load. When there's a lot of load going to a particular component, you want to put a load balancer in front of that and just horizontally scale by providing multiple instances of that service, and having the load balancer balance the load between all those instances. So yeah, you want to also so like things like event sourcing, CQRS divides the reads from the writes, so that the reads writes are more in CPU consuming tasks, while reads are less, they consume less CPU and can be cached, and can be, most of the time, a lot of stuff that is being done on the application is read, so you don't want it sucking up bandwidth from the write operations. So you separate the read operations from the write operations, and you can scale those two individually based on their nature. So yeah, then also remember to set up monitoring. Yes, if you don't want to cry I've had those sort of crying before. When applications fail, you don't want to, as the person responsible for the application, one state you don't want to be is where you don't know what failed, why it failed. You don't know what made your application go down. They call you at the middle of the night, they say the app is down, the servers are down, and you don't have monitoring in place to to show where the failure happened. You've not instrumented your architecture, your design, to make sure that you are monitoring, you are collecting metrics, you are collecting logs and visualizing them in some sort of way to be able to identify what the issue is. That's a big problem. Make sure you always instrument monitoring into your application, especially the core things in your application that need to be well monitored. The main points that if they fail, the application is going to go down. Those are the places where you want to instrument the most. So make sure that you set up monitoring for your application. Now, what's the output of this process? Definitely architecture diagrams, a lot of architecture diagrams for the whole application, for different parts of the application. That's different modules, different services, different components, different diagrams for that. Database models, database optimization designs and stuff like that. You also document your trade-offs, because there's no perfect architecture, so you want to know whether you are compromising performance for consistency at for some particular points, whether you are sacrificing availability for performance in some places. You want to make sure that those things are documented so that you know why you made those decisions. Compromises around the application, any important decision made around the architecture, you want to make sure that you document it. So that's the third thing. Make sure you design your architecture thoroughly. Now the fourth thing, we're on number 4 already. The fourth thing you need to do is to choose the right technology stack. Choose the right technology stack to implement your architecture. Now, architecture is a big picture. It's mostly diagrams, and your components are going to be named with generic names like load balancer, metrics collector, CQRS and stuff. Just the technical names for what you're trying to do. But it is some certain technologies that are going to implement those things. If you want to do service discovery, if you put in a box service discovery is not something that is not the name for the product. You need something like Zookeeper to do your service discovery for you. So it is those components that are going to do the actual work. The architecture is just a zoomed out view to see how everything is going to be structured based on the type of application you're building. So, and when you're picking these technologies, you have to make sure that they are compatible. Just like you want to pick a compatible charger for your phone, you want to pick compatible earbuds for your phone and stuff like that. You want to make sure that you pick technologies that flow optimally with your architecture. So that is why you need to choose the right architecture. So what do you need to do in this stage? What are the things that you need to do? First, you need to decide the areas where you're going to do things from scratch or use managed services. The area where you're going to do things from scratch or use managed services, you want to know that. For example, if you need a load balancer somewhere, you can use Nginx. You can use Nginx. You can spin up an Nginx server and use it to load balance at that point. You can also use something like HA proxy. You can use any of these two. But you can also use something like AWS API gateway. AWS API gateway. No, spin up something on AWS. Not API gateway, I think it's ELB. Elastic Load Balancer on AWS. You can use the Elastic Load Balancer on AWS to achieve the same thing. Then you have a managed service. You don't need to spin up the server yourself or maintain it yourself. No, you just need to configure ELB to help you do your load balancing. So you have to determine which parts of the architectures are going to be things that you're going to deploy manually and which ones are you're going to use managed services for. And definitely you can use a mixture of both. Like I said, you decide which ones are going to be deployed manually, which ones are going to use managed services for. There are people that they go totally on the route of managed services, like their entire stack, their entire architecture is on Azure, their entire architecture is on GCP or AWS. There are some people that they are not spinning up anything. They want to use managed services for everything. They don't want the headache or the overhead of managing servers and stuff like that. And some people are hardcore. Everything from scratch, message queue from scratch, everything from scratch. So you can choose to go anywhere. Another example, like for example, message queues, you can decide to spin up RabbitMQ and configure it by yourself. You can decide to spin up Apache Kafka and configure it by yourself, or you can just use something like AWS SQS or any of the Azure. I think Azure has a bunch of message buses like that you can use. So you can use you decide which parts of your application are going to be implemented with managed services and what are going to be done from scratch. What are going to be deployed by yourself, and you have to manage the server. And also you need to plan out your DevOps strategy. Have a DevOps strategy. whether you're also going to be using a managed service like Circus CI or Travis CI for that, or you're just going to be deploying your own Jenkins or your own deployment server with Jenkins. So you have to pick the right technology. You see, now I'm not just mentioning stuff like CQRS, circuit breaker, load balancer, metrics collector, and stuff like that. I'm mentioning technologies. You have to pick the technologies that are going to implement those things, and some technologies work better with each other than others. So you have to know which one to pick. What are you picking for your log collection? Are you using Splunk, or are you using something like the Elasticsearch? There's Elasticsearch, Kibana, and Logstash. Yeah, Logstash. That's the L part. Yeah. So what's the output of this? Definitely you update your PRD, that's your product requirement document, with the technology stack. You also do capacity planning. You might need to do some tests, some load balancing tests and stuff, some load tests, not load balancing, some load tests to have proper capacity planning. And also you also need to do cost analysis. You have to be able to come down to the dollars and do cost analysis for all these services, how much you're going to be spending, so that you make sure that everything is within budget. So yeah, that's the fourth thing. Like I said, yeah, that's the fourth thing. You have to pick the right technology stack. Some technologies work better with each other, but with experience, you know which one works better with what, how to get the best out of these technologies. The main thing is that you look at every component in your architecture and you pick the technologies that you're going to use to implement every single component in that architecture. So the last item on the list, the last thing you have to do. Now, this list is not set in stone. It's not like these are the only 5 things you need to do, but for me, these are the core 5 things that must be done before you start your software project. And the last one we're going to be looking at is that you need to set up your development environment and version control. Yeah, you need to set up your development environment and version control. This is very critical to managing the operations of your team. I remember those days when we used to do zip file driven development. we used to version our file on zip files, like 01 bug fixed, 01 final, 01 final, 01 last night. So, and you have to mailing zip files to each other, and one guy is like the central guy, is like our leader. He will just combine everything and deal with so many bugs. That was because we're not using the version control system like Git. So to make sure that your team collaborates effectively, you manage release cycles, you manage feature flags, you manage deployment strategies, app versioning, everything has to go through a version control system. You need to set up a version control system, and also you need to ensure that your developers have all the tools and technologies on their system to be able to carry out the project. So what do you do in this particular step? Definitely you make use of a versioning tool like Git. I think there used to be one called Mercurial or something, but Git is the most popular. So for the local version maintenance and communicating with a remote repository, you use something like Git on your local development engine. Then you set up a remote repository on places like GitHub, GitLab, or Bitbucket. You host your code there, and you make sure you set up approval workflows for things like pull requests, code reviews, and even merging and deployment. You make sure that you set up approval workflows for stuff like that, so that you don't push bugs into your the application. And also, like I said, you need to set up your team's development systems. Make sure you're setting up everybody's systems according to what they're doing. Yeah, there was a team I started work at a particular place as a team lead, or the software team, and but I didn't start as the software team lead. I started for the front end. I was just the team lead for the front end. And before I got there, every front-end developer had Visual Studio on their system. Not Visual Studio Code. Visual Studio. And you know how heavy Visual Studio is. You know even how long it takes to install Visual Studio, and how long it takes to load. And these guys were using like 4 GB systems. So the first thing I told every front-end developer, remove Visual Studio Code. They said, yeah, they wanted to be able to run the back-end code, so that what are Postman mock APIs and other mock APIs doing? Now you cannot take advantage of that. You have to install a whole Visual Studio on your system, run the backend code, so that you can communicate with the backend. Now that was really killing their development. So everybody uninstalled Visual Studio. Everybody's system became lighter. Their work was going smoother, and it was just a breeze after that. So you want to make sure you set up. If someone is going to be doing the designs, their system should be set up, configured to optimize their work. Front end and back end the same. That is what you should make sure you do. And what is the output of this? Definitely the output is implied. Well set up systems, properly configured version control system. Make sure that this is set up before you start your project. You will thank yourself later for doing that. So those are my 5 things to do before you start a software project. Let's go through them quickly once again. Like I said, first, you define the objectives clearly and determine the core requirements. Second, you initiate project management and communication pipelines. Third, you plan the architecture and design. Fourth, you choose the right technology stack to implement your architecture. And fifth, make sure you set up your development environment and your version control system. So when you do this, you will have yourself to thank. You will have yourself to thank because you have implemented a well-oiled machine to make sure that your software development cycle is flowing smoothly. Thank you very much. For more information from me, like I said, you can always subscribe to my newsletter. There's a link in the description for you to sign up with my newsletter. I remain your bro in tech.